Hello, 8th graders! We are down to the 7th week of the 4th quarter in Mathematics 8. This is me again, Teacher Pao, to teach you about the lesson entitled Organization of Probability of an Experiment, with the following most essential learning competencies. You should be able to, number 1, count the number of occurrences of an experiment, and number 2, organize the outcome using table, tree diagram, systematic listing, and fundamental counting principle. Let's get started. There are 4 ways to organize probability of events. We have, first, systematic listing. In this way, the outcomes for an event is listed in an organized or systematic way to make sure that none of the possible outcomes is missed out. Number 2, table. It uses rows and columns to represent the probabilities of outcomes. And number 3, the tree diagram, the pictorial depiction which is used to organize outcomes that makes use of branches to show probabilities of events. It is simply a model of all the different outcomes. Now, these 3, systematic listing, table, and tree diagram, are good options for small outcomes. But what happens when you need to figure out many possible combinations? Using systematic listing, table, and tree diagram will take a long time. Now, this is where the basic counting principle comes in, the number 4. It states that if one event can happen m ways and the second event in n ways, then both events can happen m times n ways. In simpler terms, the total number of possible outcomes is found by multiplying the number of choices for each stage of the event. To elaborate this further, let's have some example. The problem goes like this. When Carlo got ready for work this morning, he could not decide what to wear, and even worse, he did not know how many choices he had. Here are his options. He has a maroon polo, a white polo, and a blue polo. He has the choice of tan pants or black pants, and black shoes or brown shoes. How many possible outfits can Carlo make? So let's apply systematic listing to list down the possible outcomes Carlo can make out of his clothing options. So for systematic listing, you simply have to list down all the possible combinations of outfits by first writing down the number of tops. You have the maroon polo, white polo, and blue polo. Number of bottoms or pants, you have tan pants and black pants. And the number of pairs of shoes available. So Carlo has black shoes and brown shoes. Then, we can now list down all the possible outcomes or outfits in this manner. Carlo can choose to wear maroon polo paired with tan pants and black shoes. Maroon polo, tan pants, and brown shoes. Maroon polo, black pants, and black shoes. Maroon polo, black pants, and brown shoes, and so on and so forth. So in this manner, we can see that Carlo has a total of 12 possible outfits. Did you understand? Now, let's make use of a table. So let's say the first row consists of the number of tops he has. He has a maroon polo, white polo, and blue polo, paired with the type of pants he has, which are tan and black. So combining maroon, he can choose to wear maroon polo and tan pants, white polo and tan pants, blue polo and tan pants, maroon polo and black pants, white polo and black pants, and blue polo and black pants. Now that he made the combinations of tops and bottoms, he can choose whether to wear the black or the brown shoes. So, wearing maroon polo and tan pants, he can pair it with his black shoes or brown shoes, and so on and so forth. And counting the total number of clothing options he has, there are also 12 possible outcomes, and that is through table. Next, let's make use of a tree diagram. You can simply write acronyms or pictures to show the possible outfits with a special use of branches. Now, let's draw all the possible clothing options Carter has. He has maroon, white, and blue polo. Out of these, he can choose between tan and black pants. And from his shoes, he has black and brown shoes. So counting the total number of possible outfits, there are also 12. Now let's have the last, the counting principle. We simply have to get the product of all the choices available from Carter's outfits. He has 3 choices for tops, 2 choices for pants, and 2 choices for shoes. Multiplying them all, 3 times 2 times 2, we have 12 possible outfits. Can you follow? For better understanding, let's have more examples. Let's go through your activity sheet and answer the following activities. Activity 1 is entitled Count Me. We have to use the different ways, the 4 ways, to show all the possible combinations in this equation. How many types of sundaes can you make given 2 types of ice cream, chocolate and vanilla, 3 types of cones, waffle, sugar, and dipped, and 2 types of toppings, sprinkles, and chocolate chips? Now, let's make use of the systematic listing first. And here, we got chocolate for the type of ice cream, waffle for the type of cone, sprinkles for the toppings. You can also choose to have chocolate ice cream with waffle, cone, and chocolate chips as the toppings, and so on and so forth. So through listing, we make sure that none of the combinations are missed out. So there are 12. Now, how about the counting principle? So we simply write first the total number of choices for every stage of the event. So we have 2 types of ice cream, 2 types, this must be 2, 3 types of cones, this must be 3, and 2 types of toppings. So multiplying them all, 3 times 2 times 2, we have 12 types of sundaes available. Let's make use of a table. Let's represent the first row as the type of cone and the first column as the types of ice cream. You can choose to have chocolate ice cream paired with waffle cone, chocolate with sugar cone, chocolate with dipped cone, and so on and so forth. After this, you can now choose which toppings to use. You can choose between sprinkles or chocolate chip. And here are the total possible types. We have 12. For the last type, the tree diagram, again, pwedeng pictures, pwedeng drawing, pwede rin namang letters or acronyms lang ang ilalagay nyo, just like what is written in your activity sheet. So here, I made use of a picture again. So there are two types of ice cream, the chocolate and vanilla. And there are three types of cones, waffle, sugar, and dipped. And there are two types of toppings, the sprinkles and chocolate chips. Together, we have 12 possible combinations. Let's have the second activity, solving using the fundamental counting principle. So we simply have to solve the following problems using the fundamental counting principle, which is the fourth way in organizing probability of events. So here's the problem. You and your friends are ordering a pizza. There are 4 types of meat, 2 types of cheese, and 5 types of vegetables to choose from. How many pizzas could you order? So, reviewing what you learned from the basic counting principle, we simply have to write or list down all the possible choices for each stage of the event. So, there are 4 as the number of meats, 2 as the types of cheeses available, and 5 as the number of vegetables to choose from. So, basic counting principle, we simply multiply 4 times 2 times 5. There are 40 different pizzas that you could order. As simple as that. Now, for the third activity, think of my probability. You have to create your own example of problem involving organization of probability of events. Show organization using the 4 techniques or the 4 ways mentioned earlier. So, let's say this is the problem I thought of. Johnny conducted an experiment in flipping a coin and rolling a dice at the same time. The dice is numbered 1, 2, 3, 4, 5, and 6, while the coin could be a head or a tail. How many different combinations can he make from this? So let's make use of the systematic listing first. So upon rolling a dice and flipping a coin at the same time, we could see a head and 1 from the dice, head from the coin, 2 from the dice, tail from the coin, 1 from the dice, until tail from the coin and 6 from the dice. So there are 12. And for the basic counting principle, since there are only 2 events, the number of choices from the first event, flipping a coin and rolling a dice, is 6, times the total number of outcomes in flipping a coin, which is 2. So 6 times 2 equals 12. For the table, we have the first row as the total outcomes for rolling a dice, 1 to 6, and for flipping a coin, head or tail. And these are all the possible combinations. And for the tree diagram, these are the possible combinations. That's it. As easy as that. I hope you learned something from this discussion. This discussion couldn't be possible without the concerted efforts of the following grade 8 team. We have Sir Manny Ancheta, Ma'am Reyna S. Corpus, Ma'am Ophelia Mapatak, Ma'am Rowena Palaming, and Ma'am Mary Grace Talbo, and yours truly, Paula Bianca P. Cruz. See you next school year.